In the series, we already talked about how cement is made, how concrete and prefabricated panels were manufactured, what were the reasons and underlying theories for building prefabricated housing, and now let's deal with the practical process of building the prefabricated panel house together with building a new housing estate in the city. Welcome everyone to this new episode of Altengrad city in City Skylines. As with many Central European cities where the new housing was not concentrated to just one district, we will also leave the area from last time and move to a different place to the north, past the main train station where we built some smaller housing expansions in the previous decades. We will start in the time-lapse by demolishing the very old little block that was in the way of extending the street that would become the main avenue forming one of the city entrances, and then we will just place the buildings all around. But I'm going to talk more about that in the time-lapse because now we need to focus on the introduction on the construction process. One of the most striking differences of the construction sites of the prefabricated panel buildings is the use of large cranes. This was something not really necessary for older brick buildings, and it certainly wasn't necessary to lift whole building walls weighing up to around 5 tons. But now this was very much needed, and the construction process would not be possible without such cranes. But this was a big problem, and in a way remained a problem still, as it either wasn't technically possible to bring a full-sized crane to some remote construction site, as the prefabs could be planned for some small towns or even villages, or it simply wasn't economical. That's why in the 60s and 70s we can still find prefabs built from the concrete blocks that were smaller and therefore lighter than the usual panel for the whole wall. Such blocks still required a crane, but a much smaller one, or in some cases even just a mobile truck crane. That was not the case for cities, though. Here we would see huge cranes dominating the construction site's landscapes. Some of the earlier prefab systems employed the use of custom-made overhead gantry cranes, something similar that you can see in harbors for moving cargo or shipyards for just building new ships. It meant that rails would be built on both longer sides of the building, and a huge gantry crane would go over the whole building. This was only practical for shorter buildings, 4 to 5 floors, but it wasn't very practical for higher stuff and completely useless for tall tower sections. More standard-looking tower cranes would succeed these, and they would be later used for practically every prefab system. The more modern-looking hammerhead tower cranes, with the horizontal top part with the moving trolley, were not that common just yet, but instead we can frequently see the luffing cranes. This means that the arm can be rotated along the pivot point at the top of the tower, and the load is carried at the end of it only. That is roughly what I'm trying to build over here in the time-lapse, as I did not find something quite right in the workshop. The crane would not be static, it would have its own temporary rail line that it could use to move back and forth next to a building or multiple buildings it was assigned to. This is actually something really important because some layouts of the prefab housing estates were directly influenced by this approach. Architects with certain projects were required to rationalize the urban plan so that fewer crane lines would be needed, resulting in more monotone layouts. The crane line needed to be built on flat ground, concrete panels would be stacked to form the base, and on top of those, wide, heavy rails would be laid with steel or wooden ties. Straight lines can be seen more frequently, but curved lines were also possible. Now for the actual building process. So, ground needed to be excavated to make way for the foundations and basement floor, but the foundations did not differ much from other buildings, so the usual approaches would apply. We can see examples of ordinary-looking concrete monolithic, meaning cast at the site, wall footings forming the ground frame outlining the future position of the walls. In soft ground conditions, piers needed to be used. A pier would be a concrete column, either prefabricated and driven into the ground, or ground would need to be drilled and concrete cast into it. Then the frame would be built over it just like before, but we can also see examples of prefabricated wall footings placed over the piers. After that, it was time for placing the panels, and in here we need to generalize a little bit because different panel systems would have some specific details done differently in different countries, different decades, for example, but overall the process would be somewhat similar. The panel was brought from the panel factory on a truck, then it was lifted by the crane and moved to its position. Now, this is the most important part. The panels do not interlock like Lego bricks, but they are more like big building blocks that need to be tied together after they've been placed. So the panels are smaller to leave some space between them for further work. So when the crane positions the panels, workers need to guide it to its position and temporarily secure it with steel struts, braces, or other means. So that's why panels needed to have some strategically placed lifting points, various connecting areas, and also points for attaching this temporary struts for securing the neighboring panels. Typically then, a wall panel would be secured by a diagonal strut attached to a connecting point in the unfinished ceiling panel's top. This connecting point could have also been conveniently the lifting point. Now that the panel is secured, the rebar that sticks from its edges must be connected to its neighbors. Specially prepared rebar pieces would be placed into the joints to prepare for welding everything together. But some newer systems abandoned welding as it was too prone to human error and relied on warm weather. So instead, the panels would have various hooks or eyes sticking out of them that would overlap with their neighbors, and a simple locking rebar would be placed through those to tie it. Some systems had even screws. This connecting area would finally be filled with fresh concrete designed to flow into tight spaces and then left to harden. This is usually called to make the connection monolithic, but later observations have shown that it does not behave like a solid piece of concrete. The joint is weaker than the panel itself, and there could be some cracks forming there. Another little detail that helped to strengthen the connections would be the uneven surface on the side of the panel, which would help with shear loading. After the whole floor was done, some housing systems also had a prefabricated core that would be inserted into the finished floor. The core was basically a box that contained the bathroom, toilet, and space for pipes. Some of these would be from a solid piece of concrete, prefabricated in a factory, and some were steel frames with walls made of light laminate. In Czechoslovakia, it was the infamous Umakart material. Some systems did not have a prefabricated core at all and simply constructed bathrooms using panel partitions. After that, the floor would be closed with ceiling panels. These were not laid perfectly side by side, so to the half of width of the load-bearing wall below, but with a space between them. The load-bearing wall below would have special holes on the top surface in the middle, where workers would place special positioning screws to prepare a leveled surface for the next wall. Also, the ceiling panels would be connected together in this space. Fresh concrete was used again to fill this volume, sometimes before placing the wall, sometimes after. One huge time-saving advantage of the prefab systems was no need for outside scaffolding, but some outside work still needed to be done. How? By extending a little platform or like a basket for one worker, one floor below the finished level. This was needed because the panel gap must have been filled, usually with this like a putty that would stay elastic. But there are also examples of scaffolding being used, usually to do final plaster on older systems. After all the panels were placed, finishing works would be done. So laying the final floor surface inside in the flats, filling various holes, installing electric sockets, doors, windows if they were not supplied from the panel factory, and so on, just like in any other house. And that's basically it. I hope this little introduction highlights how the whole process was not actually that simple, and there were a lot of details in a typical prefab house that needed to be done right. There were many different types of connections of the panels, facade details, especially when insulated sandwich panels started to emerge, various roof details and other related hardware specifics. All of that had to be very carefully figured out by the engineers in the design phases of all the panel systems. Now let's mention some problems. Prefab construction absolutely can be messed up, unlike what Adam Something said in that Commie Blocks video some time ago. There are whole books and studies being made today on the topic of structural problems of prefabs so that we can understand and maintain these buildings a bit better. I will mention just a few because there seriously are whole lists of issues that are continuing to be addressed even today. I already talked about the problems regarding panels leaving the panel factories, but let's at least repeat the worst ones. So, low quality of concrete and inaccurate geometry of the panels. So, in other words, various distortions of the surfaces, different thicknesses, and so on. The design could have also introduced certain problems, mostly related to the details of connections, like introducing the so-called thermal bridges and so on. We will talk about thermal insulation in other video in more detail. But the largest problems were introduced at the construction sites. Workers needed to carefully align each panel. This is even visually a problem with some buildings, rooms not having 90-degree corners and so on. Misaligning a facade panel is the worst, as it introduces various problems, again related to thermal properties, but also allowing water to get into the structure and cause all kinds of trouble. Some people report that in windy weather, their carpets start to bulge as wind can blow in between the horizontal gaps. Top-floor apartments were notorious for having wet walls from the leaking roof. Water could also get inside from a poor connection below the windows. More thorough studies discovered very poor connections between panels. Workers sometimes did not even bother properly locking the rebar together, and the concrete poured into the connecting area, as we explained it before, did not have proper strength or wasn't compacted enough, leaving large bubbles and allowing corrosion. This specific problem is actually very serious, which might even lead to the entire panel just falling off the building. Various old television news or other programs clips can be found that mention these problems and even mention quite steep spending done after just months to repair some buildings. So that old communist joke about when we build the last floor, we are already refurbishing the first is not that far from the truth. Causes for this lack of quality probably varied building from building, or rather company from company. Some interviews with architects show that the general problem could have been the disconnect between all of the involved parties. The investor simply wanted to deliver the required number of flats to fulfill the plan and couldn't, most of the time, choose the construction company, or didn't care. The construction company then did what it was ordered to do without the usual, or today usual, economic motivations to make sure work was done properly, such as switching to a different company, among others. And the final user just stood in line to be assigned their new flat without having any say in the process and having close to no means of demanding such better quality. That is of course not the case for every single prefab in Central Europe. There are, for example, interesting cases of certain large industrial companies building new housing for their workers, acting as the investor, construction company, and user all in one. And the quality of those buildings is apparently excellent, which makes sense if the relationship right from the start is set so that the investor is directly interested in high quality and the end user or architect can effectively demand it. Apparently certain prefabs made for the families of military officers and policemen are also above average quality, perhaps because certain strings could have been pulled. There are also some rare cases where the architects were able to convince the investors that there is a need to invite a foreign construction company to build some specific buildings or details, and those companies of course made sure to do it right, as they didn't do such international cooperation every day. But those were all rather the exception. Nevertheless, the prefabs were constructed, people moved in, and the buildings, together with the whole estates, kept evolving. But the realities that people faced when acquiring such places to live and when living in them through the coming decades will be a topic for some other time. Just like the subjects of the overall urban planning and its evolution all the way towards the 90s. So don't worry, I know I'm barely scratching the surface with these introductions, but we are far from done with the prefabs. Okay, so that was the short introduction into assembling the prefabricated buildings, and now let's return to the time-lapse to Altengrad and explain what I'm doing here and talk about this area a bit more. Okay, so this is a construction site, as we can clearly see, and we need to make it look like a construction site even on the surface, not just with the equipment and all the buildings under construction. So until recently, this was actually really difficult to do in city skylines, but now we have various kinds of tools that are really going to help us with making this place very dirty and muddy and, well, just make it look like a construction site. So I suppose that the most important bit in here is the fact that we can resize decals with prop anarchy, with the function to basically resize any props and decals included. So as you can see, without it, this place is looking really bad. We only have that uniform looking surface with the grass. And yeah, as you can see, I can do some changes with, for example, the surface painter, but it's just looking like terrible. So we really need to include the decals. And this technique is actually something that's going to look really good because I don't really want to overlap decals. I already mentioned that many times before in different series as well. If you are going to overlap decals, they are going to start fighting between the textures on the edges, and these particular mud decals or all these kinds of surface decals, they don't really have like borders, right? So they need to be overlapped if you want to have some sort of continuous surface. Or you can do it so that the edges of the decals are going to be hidden, or they are just going to be made so that they are naturally going to blend with the surfaces. So you can, for example, divide the decals, well, with networks, as you can see in here. That's exactly the reason why I'm just connecting all the different areas with these dirty, muddy roads. So even in places where there are not going to be actual roads after this place will be done. So for example, around this excavation or like a site that's excavated for like a future construction here in the middle, and obviously all these like one-way roads for delivering all the panels, right? That's not exactly where some of these roads are going to be, and all kinds of connections everywhere else. So as you can see, I'm just resizing all the mud decals so that they are going to be fitting between the networks, and the networks are, like I said, going to conveniently divide the areas like that. And the network itself, this dirty road, has like a similar tone to all the other surfaces. So that's actually really good. So these decals, that's like the number one thing that is allowing us to do these kinds of not so great looking surfaces. So perfect. That's just allowing these projects. Now, let's go to the other side of this main avenue, because over here I am building something that's already done, even though it's like recently done, so we are going to include some of those decals, but I'm going to make them go lower so that they are going to fade out a little bit, so that this place is really going to scream that it was already finished some time ago and the construction crews just moved on to other parts of this residential estate. So in this place I'm building the non-standard experimental version of the G57 prefabs. Now in real life these are built in Olomouc in Czech Republic, and only in a few numbers because they are, well, experimental. There are few more similar ones around that city, but still not very frequently because, well, they are experimental, like I said. So what exactly is unique about them? What is that experiment? Well, this is basically what architects wanted to do when presented with the prefabricated technology. They wanted to achieve some kind of unique look while still being able to use those trending architectural principles or elements of the era of the 1950s, 60s, 70s. So these particular buildings do follow some of the architectural principles, like, for example, raising the first floor so that the bulk of the building appears to be like flying above the terrain, and just making the building wide in the middle, and then doing some sort of elements to just make it narrower on the top and on the bottom. So, and obviously it's all heavily still kind of restricted by the prefabricated technology. So it's not like crazily looking like some kind of unique projects, but these kinds of, small changes are there, and they are just presenting some kind of unique package, which, might have been kind of really interesting if this sort of approach was used for the prefabs instead of that very strict standardization across the entire countries, of course. So these particular buildings have that raised first floor. It means that the first floor has some sort of a different facade. In real life, these buildings are all insulated already additionally, so I cannot exactly tell how they looked. But I suppose that these kinds of tiles on the first floors were already present, maybe with slightly different colors, but they definitely were different than the rest of the building. Now, the sides of the buildings, like one column of windows, basically one column of the span of the ceiling panel, doesn't have the first floor underneath it, so there are these pillars on the sides. And the entire building is finished with this narrower top floor, also with this decorative outline, which is actually something that we can see on those more unique buildings in the city. So for example, the skyscraper, the central department store. So this was just an attempt to escape the monotony of the prefab design and just do something slightly different for this particular residential estate. Although architecture or the entire environment surrounding the construction of the residential estates, of course, did not go this way, and we would end up having the standardized version of prefabs in most places, even though there were quite a large number of the standardized versions. So, eventually we don't have the same look in prefab absolutely everywhere, which is, at least something. Now, anyway, in the city, we are continuing doing some details. So, for example, these night lights. I'm going to be using also the nighttime view, as you can see, but I'm just doing that to just get a better idea what kind of spacing I can do or I need to do with these lights, but I'm not going to show any nighttime views of the city because maybe you can even see it in here. For example, vehicles have very bright, like white lights, which isn't exactly accurate for these old-timey cars, and the rest of the city also favors the white colors for some street lights that are already present on networks. So yeah, I don't really want to show the Altengrad during the night, especially not in these kinds of time periods, maybe when we reach modern times. The last detail that we need to do are, for example, these trees. I am starting to use, for example, the birches in here and some kind of more like generic trees because, we don't really need to pay that close attention to the types, although the birches are going to be kind of, easily recognizable. So I'm going to be trying to do them some more. This is the transition. As you can see, the place is not particularly big, but also it's not particularly finished. As you can see, I already prepared some kind of future construction site there on the top, and the entire place is going to expand into many different directions. So, for example, we did not touch the infrastructure, which is going to be the topic of some future future expansions of this place, future episodes, probably the next decade, right? When we are going to introduce maybe some different prefab systems as well to really show that time progression. This is the construction site, and in here, the insides of the buildings, I actually paid close attention to have these G57 prefabs inside as they are in real life. Later, in some kind of cinematic shot, I'm going to show you actually like an overlay of the floor plan of like a typical floor of these prefabs. And yes, there are things on the construction site that are not exactly accurate, but this is still city skylines, all right? So please keep that in mind. I did some things intentionally inaccurate though. For example, I did not close the floors before moving to other floors in these buildings under construction. I did that purely because I wanted to have the entire construction site a bit more open so that we could see inside the buildings what's going on and see various stages of the construction, for example. So, nothing more to it. Now, also the orientation of buildings. All right, so I tried to make it, because we are in the north of the city, I tried to make it so that the finished buildings, at least, are facing with the loggia side, the southern and western directions. And yes, these buildings under construction are exactly the opposite, so I will have to turn them when they are done. Now, also, I would like to address the comments saying that the prefabs were built with some kind of preferred orientation. Yes and no, or rather, the flats in the prefabs were built with the preferred orientation. Because, as you could have seen there with that floor plan, certain apartments, and this is not just related to these particular prefab systems, but other systems had it as well, they just had, for example, one flat facing just one part of the building. They did not have all the apartments going through the width of the building, right? So that you could have the bedroom facing the east, for example, and the living room facing the west. That was only possible for the larger apartments, of course. If you had, for example, a one-room apartment, well, then you just had it facing one side, clearly. And also you had the tower sections of prefabs where you could have the entire apartment, for example, facing the east only. That's actually kind of common with some of the buildings. So, it's definitely not true that all the apartments had the same sunlight conditions or something like that. But the prefabs were indeed positioned so that, for example, in these particular ones, the entrances would be towards the east or north, right? Even though it's also not super accurate for every single prefab everywhere, right? So I suppose that's kind of what I'm trying to do with these kinds of videos in Altengrad, to just, make you think that it's really hard to generalize, even with something as standardized as the prefabs, because there were many different architects who were doing these things, many different conditions in different cities, different countries, different states, and all these kinds of things. I am going to make a video where I would like to show a couple of examples of real life residential estates and just talk about some history of them and some principles and how they evolved in time. All right, so that's going to be a topic for future videos. I really don't want to, jump ahead to that. This one was supposed to be just about assembling them. And we are going to touch all kinds of other topics in other separate videos. It's a series after all, so, I'm not going to explain every single little detail in a single episode. Anyway, that's going to be it for today. Thank you for watching. Hope you liked today's Altengrad episode. If you did, then please don't forget to do all the things for the algorithm. It really helps the channel. It really helps the video. And thank you. Big thanks to all the channel supporters who decided to directly support this channel by becoming channel members through the join button below or the link in the video description. That's going to be all. Take care. Goodbye.